Okay, let's dive into this. You sent over some really fascinating sources about Sanford, Maine. Now we know it's a bit of a surprising leader in the solar energy already,
Hmm.
but what really caught my eye is this idea that it could be a place to explore something, well, pretty groundbreaking,
Yeah.
using rain, actual rain, to generate power.
That's exactly right. And that's kind of our mission for this deep dive,
Mm.
looking at how these cutting-edge hybrid rain solar technologies could boost energy resilience.
Especially somewhere like Maine with its, variable weather.
Precisely. It's about using everything you've got, sun and rain.
So before we get to the rain part, Sanford's already got this strong solar foundation, right?
Mm.
What makes their existing work stand out?
Oh, absolutely. They really got going back in the early 2010s. City manager Stephen Buck was a key figure then, and honestly, they've become a regional force.
The force. How
Well,
so?
consider this. By July 2024, they ranked second in the entire state for solar capacity, just behind Farmington. We're talking 62.6 megawatts.
Wow, second statewide.
Yeah,
Okay. Any specific projects that jump out?
definitely. The Sanford Seacoast Regional Airport Solar Array, it's not just Maine's biggest,
Okay.
it's the world's largest airport-based solar installation. Powers something like 20,000 homes.
20,000 from an airport setup. That's huge.
Huge. And it brings in about $500,000 a year in tax revenue for
Yeah.
Sanford.
Impressive. And the sources also mentioned the CGA Brownfield project. That sounded really interesting too.
Oh, yeah. That's where it gets really compelling, I think. It used to be a toxic circuit board recycling site.
Right, a brownfield. Nasty stuff.
Exactly. They did a major cleanup, removed about 4,000 tons of waste, cost around $1.4 million.
Okay.
And now it's a 7-megawatt community solar farm, powers almost 1,000 households.
Fantastic. So
Uh,
turning an environmental liability into an energy asset.
Perfectly put. Plus, it generates $1 million annually in taxes and lease payments. It shows environmental goals and energy goals can absolutely align.
So what allowed this to happen? Was it just local initiative?
Well, local drive was key, but the policy backdrop was crucial. Maine's Net Energy Billing Program, the NEB program.
Ah, NEB.
Yeah, that program set clear targets, 80% renewable energy by 2030 and 100% by 2050. That provides a really strong incentive for projects like Sanford's.
Got it. Okay, so Sanford's clearly a solar leader. But let's get back to this rain power idea. What happens when the sun isn't shining? How on earth does rain make electricity? My brain's struggling a bit here.
Yeah, it sounds almost like science fiction, doesn't it? But it's very real science. We're
Hmm.
mainly talking about something called Triboelectric nanogenerators, or TINGs,
Doings. Okay.
right? Pioneered largely by researchers in China, actually, at Suzhou University. Basically, imagine a special surface.
Uh-huh.
When raindrops hit it, the friction, the mechanical impact gets converted into electricity. It's the triboelectric effect. It's just scaled down and optimized.
Friction from raindrops. How efficient can that be?
Well, they've made some clever advances. They use like dual polymer layers, a
Mm-hmm.
PDMS layer on top and a TSS layer underneath.
Right, material science stuff.
Exactly. And they even used, get this, DVD imprinted grooves on the surface.
Like from a DVD disc.
Sort of, yeah. Those tiny grooves increase light capture for the solar part by about 14%, but they also help generate more voltage from the rainfall, about 2.14 volts in some tests. And a prototype back in 2018 could do this while still letting 85% of sunlight through.
So it's genuinely hybrid, sun and rain on the same panel.
That's the goal.
Mm.
There's another approach, too, briefly mentioned in the sources, graphene-based pseudocapacitive systems.
Graphene. Okay.
Yeah, from Ocean University of China. This uses layers of graphene that interact with ions, like sodium, that are naturally present in rainwater. It essentially creates tiny rain-activated batteries. Output is still quite low, but it's another interesting avenue.
Okay, so the tech exists, at least in prototype. What could this actually mean for Sanford? And, for you, our listener, thinking about your own climate.
Well, think about Maine's climate. It gets around 45 inches of precipitation a year, over 130 rainy days on average. That's a lot of untapped energy potential if this tech scales up.
Right, you're turning rainy days from a negative into a potential positive.
Exactly. And Sanford's existing solar sites are perfect for integration. Imagine retrofitting those brownfield arrays. Maybe elevate some Teng panels slightly to catch runoff.
Mm-hmm.
Or think about the airport microgrid. You could add graphene-enhanced panels to help keep critical systems, maybe even drone operations, running during storms when solar output drops.
That makes sense, beyond just grid power or any other application.
Oh, definitely. Environmentally, think about Sanford's fisheries. During hot, dry spells, dissolved oxygen can drop, stressing fish. These hybrid panels could potentially power aeration systems using stored rain energy, reducing the need for, say, diesel pumps.
Okay, interesting ecological angle.
And agriculture, too. You could integrate this into automated solar irrigation systems. The rain power aspect could help regulate water release or power soil sensors' moisture, temperature without needing constant battery changes.
Right. Now let's be realistic. The economics must be a challenge, right? This sounds expensive.
It is currently. Hybrid systems might cost around, say, $0.43 per watt compared to maybe $0.23 per watt for standard solar panels. So,
Yeah.
yeah, more than double.
Ouch.
Maine has R&D tax credits. There's a 26% federal credit plus a 10% state credit. That could really help offset costs for pilot projects. And models like Nautilus Solar's community funding approach show ways to finance these things.
Okay, so potential ways to bridge the cost gap. What about technical hurdles besides cost?
Yeah, a couple of big ones. Energy storage is key. Teeing output right now is relatively low, maybe 2 to 5 watts per square meter. Enough for sensors, maybe charging small devices, but you'd need good high-capacity batteries, likely lithium-ion, to store enough power for larger uses.
Makes sense. Storage is always the challenge.
And durability. Those PDMS layers in tangs can degrade over time, especially with UV exposure from the sun. So making them last as long as a standard solar panel, that's still an engineering challenge they're working on.
So summing up then, Sanford's already shown it can lead on solar. This makes it sort of the perfect place to test out this next step, right? Turning rain from just weather into an actual resource.
Absolutely. It's an ideal test bed. It positions them to potentially transform precipitation from, a bit of a liability sometimes into a genuine asset.
And connecting this to the bigger picture.
Well, success really depends on collaboration.
Yeah.
You need the city planners, the utility companies, the material scientists all working together, pulling in the same direction to advance these technologies from the lab to rooftops and fields.
It really does make you think, doesn't it? For you listening, what's the overlooked resource in your own environment? Maybe something you complain about, like rain, that might just be waiting for a deep dive like this to unlock its hidden potential?